Hello, my name is Srirag Rajivan and I am going to give you a small presentation on the topic memory in digital systems. First of all, let's look at the definition of memory. A memory unit is a device to which binary information is transferred for storage and from which information is retrieved when needed for processing. We all know that memory plays an important role in performance, power efficiency and functionality across all the devices. Digitally speaking, a computer memory is a collection of huge number of flip-flops, which is a sequential circuit used to store a bit. Generally, memory is of three types: primary memory, secondary memory, and cache memory. Cache memory is a small memory which is situated between the processor and main memory, which is very small and have high data transfer speed. Now let's look at the classification of memory. Memory is broadly classified as primary memory and secondary memory. Primary memory is again classified into RAM, which is random access memory, and ROM, read-only memory. RAM is a volatile memory, which means when the power goes, all the data in it will be lost. But ROM is non-volatile memory. Even when the power goes off, the contents will not be lost. The different types of RAM are SRAM, static RAM, and DRAM, dynamic RAM. SRAM is composed of flip-flops and DRAM is composed of MOS transistors, which have high density and low speed. Coming to read-only memory, which is ROM, it is classified into erasable and permanent. Erasable ROM consists of EROM, which means erasable programmable ROM, and EEROM, electrically erasable programmable ROM, and flash ROM. And permanent ROM consists of programmable ROM, which is PROM. Now coming to secondary storage memory, it is classified into semi-random access and serial access. Semi-random access consists of the devices such as floppy disk, hard disk, and pen drives, whereas serial access consists of magnetic tape, etc. We all know that flip-flop is the basic unit of memory which can store 1 bit, and register is the collection of flip-flops. CPU consists of arithmetic logic unit, control unit, and registers, and the main memory consists of RAM and ROM. Coming to random access memory, we know that RAM is a type of volatile memory in digital system that temporarily stores data and instruction that a CPU needs while performing tasks. It allows fast read and write operations, enabling efficient multitasking and processing. Now we can see the basic structure of a RAM. It stores data in the form of address lines. An address line consists of group of words, and words is a group of number of bits. We can read and write using a RAM. To compute the size of a RAM, we have the equation size is equal to 2 raised to k words into n bits. For example, if the word length is 16 and we have 2 raised to 10 words, the size of RAM is as given below. We can use a decoder in between to get the k bit address. Now coming to read-only memory, ROM is a type of non-volatile memory used in digital system to store permanent data and firmware. Unlike RAM, data in ROM remains even after the power is turned off. This is the basic structure of a ROM. K address lines, when passed through a decoder, we can get the output data in n bits. The applications. It is used to store the permanent instructions and data which is critical for device operation. BIOS data is also stored in ROM memory. In embedded systems, to store the configuration parameters, calibration settings, etc., ROM is used. Now let's look at the big picture, which means the processor and the main memory. In between there is a cache memory, which is used for faster data access. The communication between main memory and cache takes place through words, and this blocks is like temporary memory, and secondary memory is like a permanent memory. The communication between main memory and secondary memory takes place through pages. This is the basic diagram of a memory in a computer. Now looking at the memory hierarchy, we can see this. The size increases as we go from registers, cache memory, main memory and secondary memory, and the cost increases as we go upwards, as shown in the graph, as shown in the figure. Access time is also required more for secondary memory, and it is like the lowest for registers and flip-flops, then cache and then main memory. So these are the references I used for this presentation. With this, I conclude my presentation. Thank you.